Hello, my name is Stephen Roberts, and today I'll be talking about the formation of the national parks and how glaciers and their movement contributed to that. So the first national park that I'll be talking about today is Yosemite National Park in south central California. It's located along the California-Nevada border in the Sierra Nevada mountains that run north to south in the state of California. And the process in which Yosemite National Park and actually many of the parks in the Rocky Mountains were formed is called glaciation, which is the process, condition, or result of being covered in glaciers. Evidence of glaciation in national parks is especially clear on the western portion of the country, in the Rockies, the Sierra Nevadas, and the Cascades up in Washington. And Yosemite is full of, your typical U-shaped canyons, ravines, valleys, glacially polished mountains, and consists of many lakes. These valleys and mountains were very uniquely shaped when about 10 to 20,000 years ago the glaciers started to melt and recede and actually carved out these massive rock formations. Yosemite was formed through a process called uplift and tilt. And in Yosemite's case, the land is located along a fault line and has been separated from the rest of the continent to the east and was actually pushed up and tilted to face towards the west. This process is an ongoing process and will continue to shape the landscape and geology and geography of the park for centuries. The most common geological feature in Yosemite is the presence of granite. Nearly every mountain, rock, boulder in that area was once part of a massive granite slab. And the most popular and famous granite features in the park, which also serve as evidence of glaciation, are the Half Dome and El Capitan. The Half Dome is a granite crest that is shaped like a dome that looks as if it has had the other half sliced off. It rises about 4,737 feet above the valley to a total height of 8,846 feet above sea level. El Capitan is one of the tallest vertical drops in the world, and it has a prominence, which means from the base of the valley to the top of the peak, rises nearly 3,000 feet to a total height of 7,573 feet above sea level. And the extreme shape of these two popular granite formations serve as evidence of massive glacial movements. As time passes on, the lakes around Yosemite will slowly fill with sediment and become meadows, and Yosemite Valley, which is the largest valley in the center of the park where the Half Dome and El Capitan are located, was actually once a lake. And on the western edge of the park, you can actually find metamorphic rocks, which are remnants of sedimentary and volcanic rocks that were metamorphosized by granitic intrusions. Now, the second park that I'll be talking about today is Glacier National Park, which is located right here in the northwest corner of Montana. Glacier National Park is named obviously for its abundance of glaciers, and the mountains in the park began forming about 170 million years ago when the ancient rocks were pushed upwards and east over top of the surface level rocks at that time. This process is known as Lewis overthrust, and as a result, it exposed some of the best fossilized examples of prehistoric life in North America. Most of the rocks found in Glacier National Park are shale and limestone, and what you'll actually notice when if you ever travel to these places, it's a common theme among the parks in the northern portion of the United States and up in the Canadian Rockies. It looks as if somebody took a bucket of gravel and just dumped it at the base of many of the mountains, and what that is it's millions and millions of pieces of shale that have just broken off the side of the mountain and just piled up at the base. Now, due to the formation process that created the national park, two sub-ranges of the Rocky Mountains formed, and these are the Lewis Range and the Livingston Range. Now, Glacier's mountains are probably some of the most recognizable in the country because they look different than any other mountain range in the United States. When I visited if I had to describe it in any way, it looked as if somebody had taken an ice cream scoop and just carved out the mountains. And here you see a picture of that I took of Wild Goose Island on Lake St. Mary, and the mountains in the background to the left. It looks as if somebody just took a scoop of some sort and just carved that out. It's a very distinct shape. Now the position of these ranges, combined with the U-shaped valley that snakes right through the middle of the park, and actually one of the most popular tourist destinations, which is called Going to the Sun Road, actually goes right along a ridge line in the middle of that valley. That paired with Lake St. Mary and the mountains around that, and the unique flat-sided and jagged-topped mountains are all evidence of massive glacial movement in the past. When the park was discovered in the late 1800s, there are roughly 150 active glaciers. Today, sadly, there's only 25 that remain, and all of them are expected to disappear completely by 2030 if current climate trends keep up. So the third national park that I'll be talking about is actually two national parks. It's Banff National Park and Jasper National Park, which is located in Alberta, Canada, about 300 miles north of Glacier National Park and 100 miles west of Calgary. And the reason why I combined the two is because the two parks are connected to each other, and their geological history and their formation is almost identical. And it's actually very similar to the formation of Glacier National Park. However, the only physical and visible differences you'll see are actually caused by the subarctic climate of central Alberta, which is slightly different than the climate in Glacier. But similar to Glacier, Banff and Jasper began forming between 80 to 55 million years ago, when the sedimentary rocks were pushed up and over the current rock at the surface level at that time. And over the past few million years, the glaciers receded, carving out the mountains and the valleys that we see today, similar to how it did to all the other parks that I've talked about. And at one point in history, the mountains of Banff and Jasper rose to nearly 26,000 feet before they were eroded away by water, which was then accelerated by quaternary glaciation about 2 to 3 million years ago. And to give you an idea of how much erosion took place, I believe the tallest mountain in that area is just under 12,000 feet. But the majority of rocks found in the Banff and Jasper area, and the Rocky Mountains for that matter, are shale, sandstone, dolomite, and limestone. And like I mentioned before when I was talking about Glacier, it looks as if somebody had just dumped a bucket of gravel at the base of the mountains. And as you can see in this picture here of Moraine Lake, you can see the broken shale that had fallen off the mountain just piled up at the base. But Banff and Jasper's formations run along the continental divide, which means any water that flows to the west side will flow to the Pacific, and any water on the east side will flow to the Atlantic Ocean or any body of water that's to the east of the continental divide. In 1885, the year of the park's founding, Banff and Jasper contained around 625 active glaciers, and this number had shrunk to about 500 in 2005, which is still a lot, but the fact that 125 glaciers had completely melted is still a fairly large number. Banff is also home to the Columbia Ice Field, which is the largest uninterrupted glacial mass in the Rocky Mountains. And evidence of this glacial receding is very prevalent in the park's glaciers, most notably Athabasca Glacier, which has receded nearly a mile and lost nearly 60% of its volume in the last 125 years.